What are you talking about? There's probably like maybe one
Mm-hmm. I know a student who asked me to do it. Lauren. One of my videos had 1,000 views.
Whoa.
Yeah, it was a pre-calculus one.
Start getting paid for you.
No. I mean, that would be nice. It's not like these are like, I don't have cool whiteboards and graphics. I mean, I have this silly document camera. So it's kind of.
You're a YouTuber.
I am. I did. I'll show it to you when we're done. The one that had 1,000 views. All right. So a vector.
It's frozen.
I'm a professional. All right. When you have the components of a vector, I want to keep consistent with how I wrote them on this. V1, V2. What that means is the vector from now on, unless I tell you it starts here, ends here, in standard position starts at 0, 0, and then the components of the vector basically tells you where it ends up. So if I had a vector that started at 0, 0 and ended here, this is not like in geometry when you have a ray that goes forever. It actually just starts here and ends at the top of the arrow. That first component is how far over it goes, and the second is how far up it goes. So already we talked about on our notes a couple days ago how you find the magnitude of something like that. So if I asked you to find the magnitude of that vector, we would just do good old distance formula or Pythagorean theorem. So it would just be v1 squared plus v2 squared, take the square root. Okay, who's ready for some trig?
No.
I am. Shout it out loud. All right, so the next thing is yesterday when we had our magnitudes, we compared to see if they were equal, and we just found their magnitudes, and I had to use the slope to decide if their directions were the same. That's not a perfect way to do it because technically the vector, it could be going like the different or opposite direction and still have the same slope, and they wouldn't quite be the same. We're going to, from this point forward, compare their angles. And so we're going back to some trig. So the ways that we compare angles, there are 3 inverse trig functions that you can use. You could either use inverse sine, inverse cosine, or inverse tangent. Do you see on your note page, I have inverse tan? Just understand though that inverse tangent, sometimes they only, I don't know if you remember when we did inverse trig functions, remember how they were only defined for part of the circle? So you're going to have to use some common sense sometimes, and you might have to add 180 because you might have to get it to quadrant 3. Okay? If you want to, another way you can find theta, so we could use tan inverse of, remember if the tangent is opposite over adjacent, the tan inverse of opposite over adjacent, which would be V2 over V1, would give us the angle. Okay. Or, but you're going to run into some of the same problems with this one too. You could say cosine inverse. If you were doing cosine inverse though, what would we use instead of opposite and adjacent? Adjacent and hypotenuse, except the hypotenuse, remember, is just a fancy name for the magnitude here. So if you were using cosine inverse, you would use the adjacent, which is this piece. That would be V1 over the magnitude. So you might see our book has that one written. Really, I don't care as long as you get the angle right. And just if I forget, we're going to be in degree mode for this unit. I think until we get to like 6.5. Okay, let's do some. 1, 2, 3, 1. So this vector starts at 0, 0, ends at negative 3, 1, so it looks like this. So theta is going to be the direction from that standard x, like kind of think of it as 0, 0, and then we rotate. So this is theta. Let's go ahead and find our magnitude first, though, the length of the vector. So the magnitude of the vector would be the square root of negative 3 squared plus 1 squared. What is that? Root 10. You can leave it like that if you want. Okay. Then, let's find theta. Which one do you want to do? Okay. So we're going to do the tangent inverse of the vertical component divided by horizontal component. I'm glad you picked this because you're going to see that you're going to have to use some common sense here. How are we in the common sense department? Oh boy. Okay. So I'm going to get my calc out. I encourage you to do the same. I'm going to just double check that I am in, I'm not. I'm going to get in degree mode. I now am, but I was not a moment ago. That's what I want. I don't want the little guy on the bottom. We ready? So I get negative 18. We'll just call it negative 18 degrees. Now, here's the little problem. Negative 18 would be down here. That's what that means. What could we add to negative 18 to get us to the right spot? Yep. So sometimes if you're not in the right spot, you might have to add 180, right? Negative 18, would you agree, is down here? But I need to get over there. How can I get over there? I just add 180 to my answer, which gives me okay. That's what I mean by the common sense, okay? So just look at the picture and make sure you're in the right spot. Okay, let's go the other direction. I think I didn't put this on here. How to go the other way. Let's write that on this sheet, would you? So I told you how to find component form if I give you the starting and ending point. I also, up here for the component form, let's do if you have the magnitude and the angle. If you have the magnitude and the angle, what we would do to find the component form is you would take the magnitude times cosine of the angle. Can you read that? So magnitude times cosine theta and magnitude times sine of theta. And once again, that if you want to just make a triangle and use SOHCAHTOA to do it, you can do it that way as well. So to find the component form when you're given a magnitude and the angle, the horizontal one, magnitude times cosine of the angle, magnitude times sine of the angle. Can I what? We used this a lot on day one, but this is the one you're going to use the most to find the component form. Okay, so what I mean by that is, if I gave you this and I said, I want you to tell me what the components are. So what's the magnitude of the vector? It's written right on it. 35. This 35 here means it's got a length of 35. And what's the direction angle? 60. So the horizontal component would just be 35 times cos of 60. And the vertical would be 35 times sine of 60. Let's do that. I got 17.5 and 30.3. Because I'm a fast typer. Okay. But I'll wait. How are we doing? Did you get the same thing? Okay. The last thing I want to do is talk about, like, really what do these mean? What do vectors mean? And so I want to first talk about navigation, because it's important to understand if you would go into navigation, like be an air traffic controller or something like that, that they don't talk about angles from standard position being down here. They talk about bearings, and so bearings are from the north. Did you know that? Have you heard of that? You just learned it right now? Okay. So if I tell you, are you having a hard time? Yep. If I tell you that the bearing is 65 degrees today, I'll give you a little hint with bearing. If you want to, you can always do 90 minus the bearing to get an angle for theta. Okay? Or if you're a common sense type of person, you can just draw it and figure it out. So if you like a formula, that's your formula. So if I have a jet, compass readings are from the north. A bearing is 65 degrees from the north. So it drops 65, let's see, that's clockwise from the north. So it would be like right there. So if we're thinking of this as theta and xy axis, what would theta be then? To use our formulas, I need to know what it is, the theta from the x-axis, and it would be 25. Do you see what I'm getting at here? How you could do 90 minus 65 to do it? Now, if it's in another quadrant, then you might get a negative value, but it's going to get you to the right spot at least. Okay, so my bearing is 65, but my theta is 25. If I'm talking about a jet, its magnitude is the speed. Okay, what's the speed that you're given? 500. Okay, so let's write the component form. Remember how I said it's magnitude times cosine the angle and magnitude times sine the angle? So it would just be 500 cosine of 25 and 500 sine of 25. Okay, I need some helpers.
That equation always works. That equation always
Which equation? For component form?
like the magnitude times
Yep.
the sine.
So magnitude times cosine of the angle and magnitude times sine of the angle.
Makes it 211.2.
450.
30.
0.1 or 2. Are you supposed to round?
Just do 0.2.
0.15. So
Ooh,
are we supposed to round?
sure, or chunky. Fives are always hard, aren't they?
211.3.
I didn't really give you instructions on that. So, okay. All right. So basically that means if you want to think of the plane, it's kind of, if you broke up the vector, okay, into a horizontal and vertical, you got to think of it's like 45 or 453 miles per hour of that 500 is pulling it this way, and then 211 is pulling it that way. I know it doesn't really work like that, but that's kind of what it means. It's going more this way than it is this way. Does that look like that vector of 25, hopefully, like it's going to be for, I know my picture's maybe not good, but if it's a 25-degree angle, it's going to be going more to the right than it is up. All right, you guys, stay with me. Hey.
You won't leave me.
Okay, so, last question is the tug of war question, kind of. The camera can't catch the tug of war, I know.
I'm ready.
I'll give the kind of the instructions, and then we can do. It's not really tug of war. We'll have to both try to move an object. Basically, the idea is if you have two forces acting on something, the way that the object is going to go is the sum of those vectors. Okay, so if I had this force. 75 pounds would be the magnitude, angle of 30. That's going to pull the object in that direction. And then I have a second force, 100 pounds and negative 15. That's going to be the second vector. So let's say I had something, I don't know, a box. If thinking of the box, let's put the box at the origin, okay? Basically what I'm saying is if I had an object on 30 degrees looks maybe like this, and it's 75 pounds. So we have an object pulling the box this way. And the second force is more magnitude, okay? So I'd make it a longer vector. So it's 100 pounds, and it's pulling down negative 15. Can somebody kind of point for me in what direction-ish is the box going to go? Yeah, I mean somewhere over here, right? What we're going to try to do is find exactly where. I'm going to write my component form up here. How would I find the components of this one? 75 times cosine of 30? 75 times sine of 30. Don't do it yet. We're going to type it all in together, okay? Because I'm going to add them together, and then I can just do them both at the same time. What would be the components of this vector? Be careful if it's dipping down that we actually use the negative 15. 100 cos negative 15. Yeah. Be careful that you don't make this mistake. Sometimes I'll have students and they just say they just try to find the new magnitude and they say it's 175. And then they add the angles to get the, no, you got to add their component forms, okay? I'm going to put a big old plus sign here. If I put that there, do you know what we're doing? We're adding them together. So to find the new verticals, or sorry, new horizontals, I'm going to add these two together. This one plus this one. Okay, let's do it. So 75 cosine of 30, make sure you close your parentheses, plus what was 100? cosine of negative 15 is going to give me my new horizontal component. Warren, is that a phone that I see out? Oh, okay. I thought you had something else. That's what you got. I got the same thing. So I get 161.5. Sounds like you did too. And now I add the verticals together. Gosh, you can't see that, can you? It's terrible. Can't wait till I get my new thing, but it's probably not going to get here by the end of the school year. There we go. I'm adding those. I got 18.1. Is that what you got?
I got 11.6.
I got 11.6.
Oh, I see my mistake.
I got 11.6.
See, this is good. It's good that we do this. I used a 75 again, and I should have used 100. 11.6. Yay! Okay. From this point, if I asked you to, could you find the magnitude of the new vector?
Yeah.
And find theta? Okay. So basically we know now it's going to be somewhere up here. So theta would be positive. It would be less than 30. Okay. But that's its new vector. Okay. Very nice.